Arvind, just a quick question to add on that. So, can we also push from HDFS to DBMS, RDBMS? Can we push Avro data file
You have no data file. Generally, I think the example mostly,
as an export command?
yeah, because export command will not should work. Let me check it and get back to you. Okay.
Yeah, sure. Because even in RDBMS, we store row wise, right? Data we store as row wise.
That is fine because even text file is a row wise, Avro is a row wise, but Avro is a compressed, right? Okay.
Okay.
That's the thing, right? Because any particular attribute we need to use in the export command, then it
Hmm.
can parse the file locally. And then otherwise, the other option is you can convert Avro to text file data, and then you can use even you can use the Hive table, right? To or Hive to you can do export.
Okay.
That is possible. Okay.
Yeah.
So okay, so we have already seen the Python. Okay. So next we are going to and PyCharm setup everyone has done PyCharm setup. It is a community version of Python PyCharm. And last time I have right how to add the PySpark, right? So if you want to run any code right for the PySpark, we can run right. That setup I already do. Okay, so first I start the basic Spark concept, so then we will move on to the okay. Okay. So first we start the Spark fundamentals, okay? And this is our second module. Okay? Spark is the second module in the on-premises. Okay. So first is Hadoop, second one is a Spark, and then we have cloud. Okay. So when we start the Spark, okay, so first of all, we compare MapReduce with the Spark because in Hadoop, there are the three analytics tools are there. In Hadoop means Hadoop ecosystem. Okay. So Hadoop ecosystem, we have three analytics tools. One is Big is there, Big Hive is there, and MapReduce is there. So Pig we have not done. Right? Pig we have not done because Pig is outdated in the market, and Pig is basically generated by Yahoo. Facebook Hive is generated by Facebook. Pig is generated by initially, but later on it is given to the Hadoop ecosystem. Okay, so nowadays we are not using Pig at all. Hive and even MapReduce also we are not using. Now we are comparing with these three analytics tools with Spark. Okay, so Spark is we can say we can instead of using MapReduce we are using Spark instead of Hive. But Hive is we are not completely saying right it is a replacement, right? And we are using Spark in place of Hive. Okay, Hive is still used. Hive Spark integration is there because Hive is analytics tool as well as storage, right? Like underlying storage for the Hive is Hadoop file system, right? But MapReduce and Spark, they don't have underlying storage Hadoop file system. They are processing engine. So that is the reason our main comparison is between the MapReduce and Spark. Okay. So when we compare MapReduce and Spark, so MapReduce is only batch process. So MapReduce is only batch processing. We can process only batch data, process only batch data, right? Historical, historical data. The data is historical data like weather forecasting data, right? Last 10 years, 5 years data. So that kind of historical data processing we do in MapReduce because we have data in very bulk and we are going to process the data to do the analytics. Okay? And Spark is batch and real-time both. Okay? It is processing. So first very basic difference is it is only batch and it is processing batch and real-time. So now new things come here real-time. What is real-time? Real-time data right? Data is on the fly is coming, right? Right, data is generating on the fly. Like I can give some example like streaming data. So streaming data is coming on the fly, right? Cricket streaming or like some uh, uh, Twitter. Twitter is a hashtag. So Twitter streaming data is there. Okay. Or we can say some example for the real-time streaming like credit card swiping data. So credit card swiping data is real-time data, right? So these kind of real-time streaming data we are processing also. Okay. So we'll see that how Spark does it. Okay, but Spark is meant for both. Okay. Another difference, like I say, MapReduce and the Spark, that is another big difference. MapReduce, when it is processing the data, okay, when it is processing data, the intermediate output data, intermediate output data is stored every time on disk. Okay, for for further process, further process, for further processing. What it means, like if I say I'm processing the data, 1 GB data. So once data is processed, the output data will be stored in the disk. Again, it has to read the data for further process. So there is IO, input output processing, input output processing is involved. Correct? Right. But in case of Spark, Spark is considered in-memory computation. So Spark is in-memory computation, in-memory computation, like it is processing the data in memory. Okay, but sometimes it's also using the disk also, because ultimately disk is the storage, right? Because memory is a volatile, right? So every time the data cannot be, because sometimes final storage is the our disk, right? So it's processing data in memory and further processing or further processing, further processing. So that is the reason Spark is needed more computation. That is the reason Spark needs more configuration, memory configuration, RAM configuration, more higher, more higher, more higher memory configuration, okay, in compared to Hadoop. Okay, so this is the reason, right? You know, Spark is in-memory computation, and it is more higher configuration than the Hadoop. Okay, and in the MapReduce, it is not a iterative process model. It's like if your job got failed, your got failed, job got failed, it will start from the scratch. It will be starting from scratch. Okay. In Spark, case of a Spark, it is maintaining that. This is the new keyword, maintaining that direct acyclic graph, direct acyclic graph. So it is a graph of operations. It is a graph of operations or states, okay, to maintain, right? Maintain states. Okay. So whenever whenever any kind job got fail, job or fail, it will it will start from the same place. So there are some more terms will come, lazy evaluation, and okay, I will come one by one. Okay, so this is a three basic difference, and like I can say the Spark is, so Spark is 100 times faster, 100 times faster in memory. So if I compare, right, Spark with MapReduce, so 100 times faster in memory and 10 times faster in the disk. So 10 times faster, still it is faster, but disk processing, it is 10 times faster only. But memory, it's 100 times faster in memory as compared to time faster as compared to memory. So And the other factors not to use MapReduce, the one is like productivity. So productivity is very less. Productivity is very less if the writing 200 lines of code, right? Like for same word count program, some word count program takes 200 lines of code, right? Lines of code, okay? But same code in a Spark takes 3 to 4 lines, 2 to 4 lines. Spark library, okay? The Spark library, okay? So Spark has different language support is there, right? MapReduce code we are writing Java or Python, but Spark having Java, Scala, Python, and R. R is also a one programming language, generally used Python. Python and R mostly used for the data science project. Okay. And Java, Scala. So native language of Spark is the native language of Spark is Scala. So Scala is a language. It is called scalable. Scalable. So scalable language. So basically, it's running same Java JVM. So JVM, you know Java virtual machine, right? Java runtime environment. Okay. This Java runtime environment is basically used to run a Java code. The same Java runtime environment is used for the Scala also. Okay. So Scala doesn't have its own JVM. Scala use the Java runtime environment. But native language of Spark is Scala. Okay. But we can write the code in any one of the language. We can write the code. APIs are there. There are there are different programming API for Spark application. Okay. So Spark application we can write either in Java, Python, or Scala is a native, right? So in the native language you can write, or you can write in the Java, Python, and other languages. So that will be converted into Scala. So which one will be faster, right? So if I say the Scala code will be more faster performance wise, performance wise as compared to other programming language. So, but it's choice, right? Basically, sometimes why we go for Python. So now question comes: if we are using Spark with Java, that is a one option. Spark with R, Spark with Scala, and Spark with Python. So Spark with Python is called PySpark. It's called PySpark. Spark with Scala is a Spark Scala only. Spark Scala. And Spark Scala, Spark R, and Spark Java. Okay. So these are the four variations are there. Okay. But why we go for PySpark, right? So if our project is using machine learning data science, machine learning, data science, right? So we go for Python. And when we are using Python, we have to use Python. We have another option R also there, if project using, but Python is a very rich programming libraries are there for machine learning, so we can use. So if I compare with the R and Python, so Python is the best choice. But if my project is not a machine learning project, if the project is not machine learning data science, we know right which domain area we are using, right? Either we are using Java, Scala, like which like a machine learning or without machine learning. So if the project is not using machine learning like APIs, machine learning algorithms, so we can go for Spark with Scala. The Spark with Java option also there, where we find okay Java libraries, right? Java integrations, right? Different other tools integrations we have in Java. Then we can go with Java. Okay. So this choice we will have based on the what type of requirement is there. Okay. If machine learning logic is not there, so definitely Spark, Scala, or Java. There are two choice. But again, Java or Scala, the choice is if I want very fast performance wise application good, then Spark, Scala. But Spark, Java is still the choice is there. But where is the project using some Java Spring Boot, Java Spring Boot application. So if your application is already Java application, you know, right? Java application is front end, back end, like we can create a web application, right? So if that application is already there, then for analytics, we can use Spark Java. Okay. Because Spark Java will be best way for integrate Spark with Java. Okay. But if I'm not having any Java application before, just I'm writing only Spark application. So Spark Scala, and that application is not using the machine learning, then Spark Scala is a best choice. Okay. Is clear so far? Okay. So now we come to the Spark fundamentals like Spark architecture. Okay. So for anything we are going to learn, we need to understand its internal architecture, right? How Spark works basically. Okay. So when we talk about Spark has different components out there, right? So Spark having that there are various components out there. So in the Spark architecture, there are the various components are there. Yeah. So if I say first, you know, right in the MapReduce also we have used a driver, right? So here also Spark, we have a driver. The driver is nothing but the main application code is called driver. Okay. So any code, right, which is having the main function. So why it is called driver code? Because it is starting point of your application. So that is the reason we say driver. Okay. So when I say I have a driver program, okay, and that is basically when we are submitting a job, when we are submitting Spark job, right? So there is a Spark submit command is there, command line, right? Just like a Hadoop jar command you've seen there in the Hadoop MapReduce. Here is a Spark submit is there. So Spark submit, there are the various parameters there. But here is you are Spark submit, you are doing either for Spark Scala, Spark Java, Spark Python. So there is a different way is there. Because Spark Scala or Java, both are using the jar, right? Because the application is a jar form. But Python is not having the jar concept, right? Python is directly py file is there, and that py file name you are giving directly in the Spark submit. Okay? So Spark R is also using the .r file. .r file is there, same like Python. Okay. So when we are submitting our Spark submit program, and this Spark submit program basically calls cluster manager. So what is this cluster manager? Cluster manager is basically a component in the Spark. There are three types of cluster manager is there. First one is the yarn cluster manager. Second one is the mass source. And third one is the standing one. Okay. So for our use cases, two are only there, yarn and standing. So either our application is a Hadoop based application or our application is without Hadoop. And one more advantage in the Spark is like suppose there is no dependency on the Hadoop file. You know, right? When you are running a MapReduce code, you need a Hadoop dependency. You have to upload the data on the Hadoop file system, then only you can process the data, right? But suppose I don't have any dependency on the Hadoop file system, so I can use the cluster manager external. So we need to tell the parameter in the, there is a minus master parameter is there. I have to tell here by either yarn or and stem one. So we can tell this parameters which is talking about which cluster manager you want to use. So if you know your data is not there in the Hadoop file system, okay, so then definitely you will go for scanning, because unnecessary you will not use the yarn cluster manager. And Mesos is a one other cluster manager, but different types of server, because we are not talking about here when we are doing the Hadoop based application or local application. Okay. So when I say the cluster manager is called by the like a Spark application, right? Driver program is submitting the job, right? Job is submitted, driver program, and then it calls a cluster manager. So what is the role of this cluster manager? So whatever type of cluster manager using, either yarn or scanron, it will it will allocate work to executors on workers. So they are the master slave architecture here. The driver program node is your master and the worker node are right those here. So this allocation of the work is done to the executor, allocate the work to the executors on worker node. So there are the different worker nodes are there, right? Your data is available on the worker node. And these workers node having the executors, executor is nothing but which is executing the task on the worker node. It will allocate work to executors on worker to perform perform task. And once task completed, it is using cache. So cache is one internal component in the worker, right, to store the data in memory. Cache to store data in memory for further processing. Further processing. Okay. And finally, your task is done. Finally, your tasks are done by all worker, all executors. Right? We say executor. All executors on workers will be will return to cluster manager. Your cluster manager has allocated the work and it will be taking a result to back to the cluster manager, and then cluster manager will return to driver end user. Okay. So driver program will get the final output and it will be given to it will be showing to end user. Okay, who is requesting this program to send. So it's a completely programmatic approach, right? This is a completely programmatic approach where your these internal components, right, so start working on the task, basically the performing task. So here everything is related to the hardware. Okay, if I say here is a three terms will come, right? Number of cores. Cores is the processing unit. Cores is the processing unit. Okay, like how many number of cores are used by your program to execute a task. So if I say like 3 cores, 4 cores, the parallelly the cores are running your program. Like your program is divided into the task, and each task uh, is running by the number of cores. Number of cores means different cores are running. So parallelly, the processing unit to run parallel. Okay. And second thing comes memory. So there are two types of memory is there, like executor memory and driver memory. Okay. Driver memory is the driver having its own memory also, right? But executor memory is always like matters more, right? Because executor is performing your task, right? So it is doing more calculation. The driver memory is like when the data result is coming back, so that data will be stored in the driver. Okay. Or when it is giving the data to the executors, that time it will be using the driver memory. But executor memory is while performing the task, your memory. So sometimes you will see some out of memory error will come. Out of memory. So out of memory is a Java error, right? Like sometimes you have seen like out of memory in Java, Python, anywhere it can come. So we say like it is because of heap space. Okay. So heap space, because of the heap space, right? Like whenever the variable is allocating the memory, so those are not released. Okay. Suppose your task is done and memory is not released, so what will happen? it will be giving end of the day out of memory. It will be giving out of memory error is coming at which point? Whether this out of memory is coming in the executor side or driver side. So we need to debug it. We need to debug it. We need to debug. So we need to find out whether our memory is weak or memory is to is the executor side or driver side. Okay. Then we can redistribute the this memory allocation. Okay. That way we can avoid the memory issue. Okay. And the next thing is, okay, cores are there, memory is there, and disk space is there, right? So core executors, core and number of executors. The number of executors also, the calculation is there, right? Like, okay, how many number of executors are there in a workflow? Okay, how many executors in per node, per node. Okay. So I will take an example and I will show you, like if suppose we are taking this much of size of the data and we are processing the Spark, how Spark is processing the data in a faster way. Okay. So this calculation is basically we drive it. We just calculate the all number of core executor, driver memory, okay, executor memory. So this all matters, right? Basically in the processing of the job in the Spark, because already I talked about, right, because it's an in-memory computer, right? So it's most of the data, right? It's a processing the memory, less IO. It is doing very less input output. So it is trying to process the data memory itself more and more, right? Data processing. Spark is having the 5 modules. Okay. So if we talk about the Spark 4, Spark 4 is a base module. That is basically Spark 4 is the base module, and that is basically related to Spark transformation and action, and action. There are the different transformations are there. Transformation nothing but like if I'm saying I'm converting the data from one form to another form. Suppose I say I have like 10 columns data. I have 10 columns data. And now I want to reduce to the 5 columns. Okay, so I will remove the column. So that is like I have used the, or I can rename the column, or I can do like grouping the column, or I can do the join, I can do aggregation, I can do union of the record of the two data sets. Okay, or in the same data set, I can filter, right? If I say I have a city column and I want to filter the data based on the city. So suppose I have 100 records, but based on the city, I'm getting only 10 records for one particular city. So this kind of all operations are called transformation. Okay. Transformation also two categories are there: wide transformation and narrow transformation. Okay. So wide transformation, where the data is transferred over the partitions, right? One partition to another partition, data is transferred. So wide transformations are like join, group by key, reduce by key. So these are the wide transformations. Okay. Where data is transferred across the partition. Data is transferred across partitions. Okay. So this is internally, we are not managing that part, but it is internally done. Whenever you do any join, group by key, reduce by key, so data is transferred over the partitions. And narrow is called when the data transfer, data is like aggregation thing, like simply say, like just simple, like I just do some map operation, flat map. Okay, I will talk about this and filter. When I'm doing this type of operation, these are the data is Same partition, it is process. Same partition, it is process. So same partition is process means we don't need to do aggregation things. Like grouping generally we do for aggregation. Right? Like I want to say, I have some particular key, I want to aggregate the data from different, I want to generate the revenue based on the city. So how can I do it? I will do some group by operation, right? Based on the city, right? Is clear this one? Narrow and wide. I will explain more with the example. Yeah. So I'm just talking about here the what is a Spark core module. And another module is the Spark SQL. Okay. So the Spark SQL is basically the SQL module, like where we are reading and writing data from the some data source. Okay. So what could be the data sources could be there? I mean, file system and data source. Okay. There is another data source is the SQL databases like RDMS database. So we can read and write the data from the RDMS, right? So the file system is like a CSV file, JSON file, XML file, right? So these are the data sources. You know, right, in Hive, we were using a different file format. Here also Spark is supporting all types of file formats. Okay, it can read the data from files, it can read the data from SQL databases, right? So SQL databases, we can read the data, right? So Oracle, MySQL, SQL Server, okay, Oracle, MySQL, SQL Server. So these are all databases are supported. Okay, and NoSQL databases. Okay, NoSQL databases like Cassandra, Mongo. Okay, I will cover Cassandra, Mongo. So Cassandra, MongoDB. Okay, and if I say NoSQL databases, category is there. Okay. And cloud, right? So Spark can be integrated from the any different sources, and these sources are like SQL source. Okay, and next is the module is a Spark streaming, and Spark streaming is a real-time processing. So you can say the Spark SQL is a batch process. This is a batch model. This is a batch processing model. We were talking about what is a batch. So batch processing. The Spark streaming is a real-time streaming. Spark streaming, yeah, real-time. So real-time streaming data when we are getting a data through some streaming sources. So streaming sources I talk about like Kafka is there, and Twitter is there, right? So we can get the data from these streaming sources. So we will be using Spark Streaming API. These are the three modules we have to concentrate. Other two modules are not for our use. One is the Spark machine learning. Okay, because if any particular machine learning project is there, then this machine learning library would be. So Spark machine learning. Okay, another one is a Spark graph. Okay, Spark graph. So Spark graph is like where we have nodes are connected to each other. So Spark graph is. So Spark graph is another module. Generally, it is used where we have the cyclic graph. Like there we have to represent data in the form of vector and edges. Vector and vertex and edges. No, vertex. So vertices and edges. Okay. So when the our graph is formed in the form of vertices and edges, then we use the Spark graph. So these are the five modules. Okay. So mostly our concentration only on these three: Spark Core, Spark SQL, and Spark Stream. So first, what we are going to do, first we will be doing all the code transformations. We have to understand what are the code transformations are there. And this SQL and streaming is on top of the core on. Because if I say Spark SQL just, so Spark is not only just analytics. Spark is ingestion tool as well. So Spark is ingestion and analytics both. Ingestion plus analytics. Because analytics you cannot do without ingestion. Right? If I say, if I want to do analytics, I have to ingest the data first, right? So Scoop, you know, only ingestion. Hive is like it is doing analytics, right? You are loading data into table. After that, you are doing analytics, right? Okay, but you are not writing separately any uh, load processing things, right? You are that is a part of the table only, right? You are loading the data, okay, and once the data is ingested, right? So Spark is ingesting data, so you can say that Spark is a substitute of the scoop, and the analytics part is a Hive. So these two combined together, and Spark is using in-memory computation. Okay, so just whatever type of data you want to read, you just read that type of format. Okay, so I will tell about like when we do the Spark code, so spark.read.csv. So you can read the CSV file, spark.read. Okay, parquet. So very simple, right? In the Hive, you have to use Saturday, right? You remember? You have to use different Saturday class. So here you are just simply providing the function, and then it will read the data as a data frame. And data frame I will tell about. The Spark has three fundamental data structures. Okay, one is RDD, second one is a data frame, and third one is a data set. Okay, but we will use these two, right? RDD and data frame. So RDD is the unstructured form of the data we are reading in Spark. It's a fundamental unit of the Spark, like base, right? I say the three data structures. These are three data structures. Okay, like we can measure the data either one of these three. So if I say I have a huge amount of data and I want to process data, so I will use one of these three data structures. Okay, so if I'm going to use RDD, RDD is completely for unstructured data, that audio video, not that kind of unstructured data. So if I say this text file is also unstructured, how it is unstructured? Because there is no fixed number of columns. Here is a 10, 15 column is there. Here is only 3 columns is there. So it is the unstructured form of the data. So unstructured form of data means text file is a unstructured form. Okay? So text file, which is unstructured form of the data, unstructured form of the data, and RDD is doing row by row operation, row by row operation. Okay, and when we come to the data frame is tabular representation data. Data frame is tabular representation of the data in form of row on column, in form of row and column. So we know, right, row and column, what it makes? It makes table, right? It makes table. And generally we do the operation on the table column. So operation is done on table column. So you can say clear difference is here. Here is the operation is row by row. Here is column by column operation, right? So you do column by column. Okay. So which one is more easier to processing the data? Row by row or column by column? Column by column is more easy. So data frame operations are easier than, right? Writing code is easier than the data frame. Okay, because data frame is, just suppose you say you have a one column name, and I want to say I want to add some suffix or prefix in the column name. So simply you will take column and add the suffix or prefix, some string you will add. So entire column will be modified. So you don't need to go one by one row. Entire row you don't need to take, right? Because only one column operation you want to do. So if I say I have a data, three column data is there. Okay, ID, name, and city. And I'm going to say you, you have to do some operation on the city column. So ultimately in RDD, what you are going to do, you are going to ID, then name, and then city. Then you are doing some operation. Again, ID, name, city. So iteration is going through the row by row, right? But in case of data frame, you are doing column by column. Okay. So that's the advantage of the data frame, and data set is basically RDD and data frame extension, right? Whenever I want to do some object-oriented programming style of coding, so I can use a data set, right? Entity based. Okay. So I will tell the data set example. Okay. So when we are learning PySpark or Scala or Java, all are having the RDD data frame and data set. Okay, but Python is not supporting data set directly. Okay, but RDD and data frame all supported by the every programming, right? Even we go for Python, Java, Scala, everything is okay. So these are the three data structure. So tomorrow I will start first from the like RDD, and I will show this transformation. So whatever transformation you learn in the RDD, same transformation in the data frame. But the way of applying the transformation and action is different, because here is the row level operation, this is the data frame is the column level operation. Okay. But first we need to understand this data structure, right? Why we RDD need, because still the data frame is easier. Why we go for RDD? Okay. So see, RDD is resilient distributed data set. So what is it is immutable. Data frame is also immutable, but there is a sometimes if I say, if I'm reading a CSV file, JSON file, XML file, so these are giving directly data frame. We don't need RDD, because these all type of file system data, XML data or SQL database data or NoSQL data, so it is directly giving to you data frame, because all these have schema. Like CSV is having the column name, JSON has the column name, XML has also column name. So when we are saying this, so column schema is fixed. Okay, so that is the reason we are getting directly the data frame. But in case when we are reading a text file data, which is unstructured data, so there is no schema attached, right? Okay, so we have to create manually schema, then RDD will become the data frame. Okay, if I say this RDD, if I plus, if I say schema attached with this RDD, then it will become data frame. Okay, so I will show you tomorrow how many ways we can create RDD and how many ways we can get the data frame, right? Okay, and RDD to data frame we can convert by using the RDD.2df function, 2df, so it will change. Okay, we have to pass the schema column and data frame you have, so you can do RDD function with 2 RDD. But why we need RDD to convert data frame? Because sometimes I want to do apply row level operations, like entire row I want to put some operation, right? Not column wise. Then I will go for the RDD. It is clear so far? Okay. Okay, I will share you some notes and the book also. At least you can start some theoretical, more fundamental. See, first you have to understand more theoretical, fundamental concept, so that you can get a more critical idea, right? Okay. So ultimately we have to do practical, right? But before going to the practical, you should have fundamental theory knowledge, right? What are the different types of modules are there? So as much as you read through the fundamental topics, so it will be new. Okay. Okay. Tomorrow I will cover further the practical part. Okay. And keep it your Spark installation, like Spark home path and Spark bin path, right? You know, right? Spark you download from the Apache Spark website and set the home path and bin path. Okay? I have already told about that. Thank you.